All right, so zeros of a polynomial. What are the zeros of a polynomial? What does that mean? What are they also? Solutions. That's another name for them. It's another zeros, solutions. There was a couple other names that we talked about. One of them started with an R. And I told you it's like an old school way of calling that. Zeros, solutions, roots was the other one. That's what we used to call it back when I was a kid, back 100 years ago. But you don't see that as much now. See zeros and solutions more than you do roots. Now, the other thing is x-intercepts. Zeros of a polynomial are their x-intercepts. And that's where the graphing utility is going to help us out today when we're trying to break apart a polynomial based on some things we know about it. So we're going to learn a lot of things about polynomials today. The first thing we're going to learn is how to make a list of the possible rational zeros. What makes something rational in mathematics world? What's a rational expression in mathematics? What kind of numbers are rational? Written like a ratio, which would normally be written as a what? Fraction. Okay, so rational zeros are the zeros of a polynomial that can be written like a fraction. Not all zeros of polynomials can be written as fractions, but what we're going to do is we're going to learn this trick about how to find the possible ones for any polynomial. And it stems from this idea of P over Q, where P are the factors of the constant and Q are the factors of the leading coefficient. There we go. Leading coefficient, which is the number in front of the, if it's in descending order. Number in front, number in back. P is the number in back, Q is the number in front. So in college algebra, I know on the EOC that you're going to see in about a month, 2 months, you're going to see a question that asks you to list the possible rational zeros. Doesn't tell you to find them, just says list them, okay? So if you're going to list the possible rational zeros, the possible rational zeros. That's all we're doing here. We're not solving yet. We'll get there pretty quickly, though. For this particular polynomial function, x to the third plus 2x squared minus 11x plus 12. Okay? What number is in front of x cubed? It's a 1. It's an understood 1 to be there. So that right there is our q. This is p. So when we're talking about p over q, if I say list your p over q, that's what I'm talking about. The factors of 12 over the factors of 1. Okay? When it's 1 in the front, this makes that really, really easy, which, most of the time, remember when we were doing quadratics, if there was a 1 in front of the x squared, it made it easy, right? Makes it easier here because you're listing your p over q. You want to think about the factors of 12. 1, 2, 3, 4, 6, and 12. Those are all numbers that go into 12 evenly. That's what factors of 12 means. All the numbers that could go into that number evenly. On the bottom, we want the factors of the leading coefficient, q. Since it's 1, what's the only factors of 1? 1, right? Nothing else goes into it evenly. So that makes our list pretty short. And I always put a plus and minus in front of it because you could be a positive 2 that goes into that, could be a negative 2. They both go evenly. So plus or minus. And then we're dividing each of these things on top by the factors that are on the bottom. So if I divide them all by 1, I just get those back, right? We'll do the next example has another number there that makes it a little bit more difficult, but not much. So what we've done here is we're taking this polynomial and we're listing the possible rational zeros. So if this thing crosses the x-axis, we've narrowed it down to 12 numbers that it could cross at if it's a rational number. Okay, 12 rational numbers instead of negative infinity to positive infinity. Okay, it could have been any number in the world. We've narrowed it down to a list of 12 of them, and that's going to help us. And we'll see how we're going to use that in a second. So let's get used to making that list first, because that list is handy every single time we do a problem, because it gives us ideas of what to try even. So let's look at this one. This g of x. We're again just listing the rational zeros, possible rational zeros. 4x to the fourth minus x cubed minus 3x squared plus 9x minus 10. Okay. P over q. What are the factors that go on top? 5 and 2 and 1 and 10, right? Those are all the numbers that go into 10. What goes on the bottom? All the numbers that go into what? 4. This 4 that's in front here. So the numbers that go into 4, 1 is always one of those. 2 and 4. So here we have 3 things in the denominator now that we've got to divide by. So we're going to have a longer list, but it's still smaller than every number in the world. So it's not like we're making it overcomplicated. So plus or minus in front. If I divide them all by 1, 1 into 1 goes one time, 1 into 2. Just divide them through there. That's just 1, 2, 5, and 10. The next thing to do is divide every number in top by the 2. 1 over 2 is 1/2, right? That's a rational number, 1/2. What's 2 divided by 2? 1. I've already got that listed. I don't have to write it again. 5 divided by 2. Do I have that written down yet? No, I don't. So that's a possibility. What's 10 divided by 2? It's 5. I've already got a 5 written down, so I don't have to write it again. Okay, so we just added 2 more, or technically 4 numbers to the list. Now let's divide them all by this 4. 1 divided by 4, 1/4, right? 2 over 4. What's that reduced to be? 1/2. Already got that one written down, so I don't have to do it again. 5 over 4. Do I have that written down yet? I've got a 5 over 2, but not a 5 over 4, so that's one of my possibles. 10 over 4. That reduces to be 5 over 2, which I've already got, so I don't have to write it down again. So now, got a little longer list here, but we've narrowed it down to 4, 8, 16 possible numbers that could be where this crosses the x-axis. What we're going to do is we're going to use the graph to help us pick one of them to use, or technically 2 of them in this case, since it's 4th power, so that we can break this polynomial down. Okay, so that P over Q list, factors of the constant over factors of the leading coefficient. Make a list. There will be questions on the quiz, on the test, on the end of course. I don't know if I've ever seen this on ACT, but that doesn't mean it couldn't be there. College algebra test and final, I've seen it on every one of them I've ever given over the last 4 years that they asked me just for that list. No math, not much math involved there, just a list. So important thing, it's called the rational zeros theorem is what it's called. But it gives you the list of the possible rational zeros is what we're getting there. All right, so now let's take this list and use it. So let's get a polynomial. So we're going to find the zeros of the polynomial. And so this is really the meat of what we're doing in this section. Find the zeros of the polynomial. Find the x-intercepts of the polynomial. Find the roots of the polynomial. Find the solutions for the polynomial. All of those instructions mean the exact same thing. So if we're finding the zeros of a polynomial, let's just start with a fairly simple polynomial. X to the third minus 8x squared plus 11x plus 20. So this is similar to what we did Thursday and Friday of last week, where you're given a polynomial. The only difference is last week I gave you one of the factors or one of the zeros to start with. Today you don't get that. So it's kind of like the training wheels are taking off. We're riding the bike two-wheeler, big boy style, big girl style. Yes, sir.
Put them back on.
Yes, I'm gonna show you how to put them back on. That's what I'm gonna teach you to do.
No, I want you to put them back on.
I'm gonna show you how you can put them back on. I'm gonna let you turn it. Okay. So here's what we need to do. Let's make that P over Q list for this polynomial. That's what I want you to do first. So number one thing to do is P over Q. So we got factors of 20 and factors of what? 1. So that means that really only thing we have are the factors of 20. Because if you divide them by 1, they don't change. What are the factors of 20? 1, 2, 4, 5, 10, and 20. So we've narrowed this down from all the numbers in the world to 12 numbers that it could be. Now, when I was a lad, we didn't have these nice graphing calculators that you have. We had to test those in the polynomial with synthetic division and find one that worked. Okay. There's a few other things that you could work out that might could help you, but it still came down to making a good guess. You guys live in a world where you have a graphing calculator in your hands. Let's use it. Okay. Let's graph this polynomial. We're going to type that into our graphing calculator. So graphing calculator, we're going to hit the y equals menu. I got some stuff in here from college algebra there. Let me get rid of that. So I'm going to go up there to y1, clear out anything I've got going on, and I'm going to type in that polynomial, x to the third power minus 8x squared plus 11x. Oops. Get one of my ones. 11x. And then plus 20. Everybody with me there? I'm going to graph that, and I've got my window kind of adjusted out weird, so I'm going to zoom 6 to get back to the normal window. Okay, so look at what are we looking for here? We're looking for zeros, right? What's another name for zeros? X-intercepts. Where's that thing crossing the x-axis? I can see right here at -1 it's crossing. It's also crossing at, it's like 4 and 5. How many times is that? 3. What was the degree of the original polynomial? 3. That doesn't always match. Giving you FYI, that does not always match. It's nice when it does, because that means we can check our answers real easily. Okay? Now, here's what you really have to do. And I'm going to show you how to break down the polynomial using one of these. Pick one of those places that you think it crosses at. If it crosses at a nice place like we think -1 is, I'm going to test that. So with my graphing calculator, I'm going to hit trace, and then I'm going to type in -1 and hit enter. And make sure it gets 0 for the y. If it doesn't get 0 for the y, I can't use that number in synthetic division. Has to get a 0 for the y. I'm using -1. You could also try 4 and 5 out of that. So here we see it crossing the x-axis at those 3 places. So that should tell us what our answers are. But we want to be able to do this even if it doesn't cross that many times. So the style you want to do that with, and here's the training wheels, Trevor, is you set up synthetic division with one of those numbers of where it crosses the x-axis. So it crosses the x-axis. I'm using -1, and then I'm doing synthetic division with that and that polynomial. So this is like last week the problems had a semicolon and then they had a -1 written out there. Today, you got to find your own -1. Okay, that's the difference in this and what we did last week. Okay, so I'm going to run synthetic division through with this -1. And that's going to give me a remainder of 0. So that means my list of zeros, x equals -1, is one of them. What did that do to this polynomial? It started out as x cubed. What's this red stuff now? It's x to the what power? X squared minus 9x plus 20, right? Which is what kind of problem? For the cube, quadratic. And we know how to solve quadratics, right? So that's what we want to do. We want to use that idea that, hey, I can solve that quadratic x squared minus 9x plus 20. What are my options for solving a quadratic? Say it again. X method for factoring, that's a great method. What's another option? Quadratic formula, x equals -b plus minus. That still works here. Once you've broken it down to a quadratic, you get all those options. Let's see if this one will factor, because I like factoring better than I do quadratic formula, if it works. So multiply to be 20, add to be -9. -5, -4. Shouldn't be surprised that those two numbers show up because we saw it crossing the x-axis at +5 and +4, right? So that's their factors, x minus 5, x minus 4, and then so x minus 5 equals 0, x minus 4 equals 0. There's where those x-intercepts come from. X equals -1, x equals 4, and x equals 5. We have 3 zeros to that. You will always have the same number of zeros as the degree, but you won't always have the same number of x-intercepts. That comes into play when the imaginary numbers come involved, like the complex solutions to a quadratic. Remember we did those back then. So we'll see an example of that in just a little bit. But you will always have the same number of zeros as the degree, but you won't always have the same number of x-intercepts. Say that one more time. You will always have the same number of zeros as the degree, but you won't always have the same number of x-intercepts as the degree. Okay, so that's important to recognize. All right, let's do another example. D, f of x. Let's do another cubic, x cubed minus 4x squared minus 15x plus 18. Okay. This should be an easy P over Q because leading coefficient is how much? It's 1, right? So we just need the factors of 18. What are the factors of 18? 1, 2, 3, 6, 9, and 18. So we've narrowed it down to 6 or 12 possible numbers that it could be. I need to find one of those that works so that I can use it in synthetic division. How do I find one that works? Say it again. Graph it. Graph that polynomial. See where it crosses the x-axis or touches the x-axis. Okay. We'll go to y equals. I think I can just edit this one maybe. Minus 4. Minus 15. Plus 18. Hit graph. I just need one to start with. It doesn't matter which one I start with. My habit is to start at the left and go right. It doesn't matter. This one happens to get all 3 of them again, but I won't always do that. We're about to get some that don't. Now I want to get the process down first, and then we'll get there. I want you to go through all the steps, yes. Because if you don't, you're going to go, what do I do now? When it doesn't give you all that. Because what if I ask you to factor the polynomial? You have to do those steps anyway, even if it's showing you all 3 years. So we got -3, +1, and 6, maybe. Pick one to try. I'm going to use -3. So I'm going to hit trace, -3, and enter. And I see that it gets me y is 0, so that means I can use that in synthetic division. So I'm going to use -3 in synthetic division. 1, -7, 21, 6, -18, and there's 0. So that gets me down to a quadratic. X squared minus 7x plus 6 equals 0. I'm going to try factoring first because I happen to know it works. This is -6, -1, add to be -7, and multiply to be +6. So x minus 6 minus 1. So over here, I'm going to list my zeros. X equals -3, 1, 6. You could just put a comma between them if you want to, but I tend to not do that. Because I just don't. I don't know why I don't. It would be easy. All right. Let's get to one where kind of goes in the direction that Trevor was asking a question about. If we see that, do we have to go through that process? And why did I want you to go through that process? It's because you may have a polynomial like this one, not x squared, but x to the 4th plus 3x cubed minus 30x squared plus 6x plus 12. So you might have a polynomial like that. A little bit more complicated, it's to the 4th power this time. So how many zeros should I have? 4. 4, because the degree is 4. Should always match the number of zeros with the number that the degree is. The degree is the highest exponent. Okay? Now, does that mean I will have 4 x-intercepts? Not necessarily. I may. That doesn't guarantee it. Okay? Just because the degree is 4 doesn't guarantee that I have 4 x-intercepts. It guarantees that I have 4 solutions or roots or zeros, but it doesn't guarantee x-intercepts. So P over Q, a little bit more complicated on this one because you got the factors of 12. 1, 2, 3, 4, 6, 12. Factors of 9. 1, 3, and 9. So we get a little longer list. Kind of handy to have this list sometimes. Not always the best, the most helpful thing, especially if they cross at nice numbers. But what if it crosses at not so nice numbers? It is kind of handy. So let's do, so you got 1, 2, 3, 4, and 6, and 12. And then 1/3, 2/3, 4/3. 6 over 3 is 2. I've already got that. 12 over 3 is 4. I've already got that. And then I have 1/9, 2/9. 3 over 9 is 1/3. I've already got that. 4 over 9. 6 over 9 would be 2/3. And 12 over 9 would be 4/3. So a little longer list on this one because I had more factors. So several there to choose from. Definitely an advantage to having the graphing calculator now on this one as opposed to the way that we used to have to do it when we didn't have that option. Okay, so let's suit up here and play the game. We need a number to go on the shelf. What number could go on the shelf here? How do we find that again? Graph it on a calculator. See which one of those rational zeros that's listed works. I have a feeling that more than one of them works, but maybe not much more than one. Okay, so we have 9x to the fourth plus 3x to the third minus 30x squared plus 6x plus 12. I'm hitting graph. So I'm looking for this thing to see if it'll cross the x-axis, touch the x-axis, something kind of nice. All right, so looking at that, I got some interesting things happening here. I know it's crossing the x-axis here and here, and then it looks like two places here. They're real close together, but it looks like two places. This one looks like what? -2. Test it and see. So
negative y equals, and wherever the x is 0 across it.
Do you mean the table? Like second graph, you mean?
Yeah.
Where the x is 0, it's where the y is 0. Yeah, and that'd be a whole lot of stabbing and guessing. That's what we're checking with trace. It's the same thing. It gets you an ordered pair just like the table does. So yeah, you're doing the same thing. You're just doing it while you're looking at the graph is the difference. So I'm hitting trace and then -2, and that works. What does this look like it might be? That spot right there. A half is a half in our list, in our P over Q list. Is 1/2 in the list? No, then it can't be 1/2. What's something that's in our list that's close to a half? 4/9 is pretty close. Is it in our list? Yeah. So I'm gonna test that while I'm here. I'm gonna go ahead and test that because I'm gonna need to do synthetic division 2 times on this one to get it down to quadratic because it starts out at 4th power. I want to get it to x squared. So synthetic division once gets it to 3rd power. Synthetic division again gets it to squared, which is what I want. So is that 4/9? So I hit trace 4 over 9 and see if it gets me a 0. Ooh, does not. That should have been -4/9. Let's try that. Trace -4/9. Ooh, it's not even that. Huh. Do we have any other fractions that are close to a half? 2/3, that's close. So -2/3. It jumped down here. So it's in between those two, but it's not in our rational zeros list. That's a 0, but it's not rational. Okay, so we may have a square root something happening here when we get to the quadratic. Look over here. What's going on here? A little tough to see maybe from where you're sitting, but if you look at your graph, it looks like it's hitting like at +1. Is it? I'm gonna hit trace, +1. Yeah, it is. So now I have two numbers that I can use in synthetic division. It doesn't matter which one you use first. I'm gonna use -2 first, and then use +1. If you want to use +1 first, that's fine. I don't care. Your answer is just gonna be a little bit different in between than mine is. Okay, so I'm gonna use -2. 9, -18, the -15, 30 at 0, and there's -12, just like I wanted. X equals -2 is a 0 of that polynomial. That started as x to the 4th power. Now this is x to the 3rd power. So I don't have any tools. You know, I could try grouping if I wanted to try to factor that, but it's obvious that that's not going to group to work out here. You got that 0 in there. So I'm thinking synthetic division again. What other number do I know works? I've already used -2, what's the other one that we said worked? +1. So I'm going to run synthetic division with a +1 up here on the shelf. Now, I get x equals 1. That's the second 0. Turns out it's the second x-intercept too. This one crosses 4 times. It doesn't always have to. Well, I think our next example does. So. Now, this is quadratic, right? 9 times -6 would be -54. Is there anything that multiplies to be -54 and adds to be -6? So, or do I even have to do that way? The numbers are getting a little bigger. It's harder to factor, right? What's the other option you've got for a quadratic? You got quadratic formula, guys. X equals -b plus or minus radical b squared minus 4ac divided by 2a. 4 times 9 times -6 divided by 18. For this one, it won't factor. I know that because I've already worked it. But discriminant wise here, we got 36 plus 9 times 24 plus 36. 216 square root of 56. Is that? No, 216 plus 36. 6 plus or minus the square root of something. What is that? 6 squared is 36 plus 24 times 9. It's 180 plus 36 is 216. Is that right? I'll check my math here because I'm trying to not use calculator. 252. Is the discriminant 252? All right. So I need to break down 252 and simplify that square root because I want an exact answer, right? Well, yes, I do. So, FYI, exact answers are the way to go. And then we can get a decimal approximation for that. All right, so that'd be, 226, 2 and 63, 9, 7, 3 and 3. So a pair of 3s, pair of 2s. So that's going to end up being 6 plus or minus 6 radical 7 over 18. And that'll reduce because these 3 numbers are all divisible by what? 6. So that's 1 plus or minus 1 radical 7 over 3. There's my third and fourth x-intercepts. There. So I go to my calculator and I type in trace parentheses 1 plus the square root of 7 divided by 3. Look at there. There's my decimal approximation. There's y being 0. Does the same thing if I do the minus. You can always check these out of that. So this one had 4 x-intercepts. It had a degree of 4. That doesn't always, it's not always the case. And it's not always the case that all 4 of your x-intercepts are in your P over Q list. That doesn't always go together. Okay? Let's look at example, whatever letter we're on, F. Seems fitting. F of x, x to the fourth power minus 22x squared minus 75. Let's try to solve this one the same way we've been doing this one. This one can be done a couple other ways using what we did last week. But let's try to do it through the pattern that we're trying to learn today. P over Q is going to be a pretty tough list because you got all the factors of 75. 1, 3, 5. 5 goes into it. Let's see, 15 goes into that, right? 5 times 15. That's what that is. 3 times 25. And then 75. Well, that's actually not that bad. Okay. Now, the next thing to do, is what? Right. Why did I put all those zeros in there? Yeah, because there's not an x to the third power, so I got to have a representative. There's not a plain x, so I got to have a rep for it. Okay. Where does it happen to cross the x-axis at? So x raised to the fourth minus 22x squared minus 75. I can only see two places where it's crossing, which is handy because I need two of them, right? If I start with fourth power and I want to get it down to a quadratic, how many times do I need to do synthetic division? 2 times. Once to get it to third, another time to get it to squared. Okay. So what number is this? -5. That other one over there would be +5. I'm going to use those two with synthetic division. Doesn't matter what order you start with. I'm going to start with the -5, get the hard part over. And that'll give me 3. And there's my 0. So x equals -5. And then I'm going to run synthetic division with what's the other number? +5, yeah. 1. There we go. And then so what's this polynomial I got left here? X squared plus 3 equals 0. How can I solve that? I could do quadratic formula, but b would be 0, but I could still use quadratic formula. What's another option that we learned back in chapter 4? It's just got an x squared in it, so no, there's no such thing as sum of squares. There's a sum of cubes, but that's not cubes. Square roots, folks. Take the square root of each side, but I'm taking the square root of a negative number. So what's that do? Makes it a complex number out of the I comes out. So plus or minus I radical 3. The complex solutions don't show up on the x-axis. So this is one of those where we've got 4 solutions, 4 zeros. We've got a +5, -5, and then we have the plus or minus I radical 3. Those are zeros, but the plus or minus I radical 3 doesn't show up as an x-intercept. Okay, so those are, they exist as zeros or roots, but they're not x-intercepts. So this is one of those where it doesn't cross the x-axis as many times as it has zeros. It always has the same number of zeros as the degree, but not the same number of x-intercepts as the degree. Doesn't always have those. Okay. I don't know. And cross that bridge, yeah. We'll get there eventually. Right now, no. All right, let's look at section 5.7. Building polynomials. And remember, the first part of chapter 5, we spent some time multiplying polynomials together. That's where this the reason is this, to build a polynomial. Given the zeros, build a polynomial. All right, so example A, zeros are 2, 3, and -1. Okay, so we're given the zeros, and we want to take that and go backwards and build the polynomial that came from. So what the first part of the lesson was taking a polynomial and breaking it apart and getting the zeros. Now we're getting the zeros and building the polynomial out of it. So it's going the other direction here. So the key to this is the factors that each zero represents. What's the factor that goes with x equals 2? It would be x minus 2. Let's just swap the sign. That's all you have to do. So the one that goes with +3 would be x minus 3. What about the one with -1? Be x plus 1. Okay? There's the factored form. So this is factored form. Let's get standard form. To get standard form, you multiply this out. It's multiplication, so it technically doesn't matter what order you do it in. I'm going to show you the way that I do it. If you want to do it in a different order, it's fine with me. But I just kind of start with two of them, multiply those two together. So that'd be x squared plus x minus 3x minus 3. Hadn't done anything with the x minus 2 yet. I'm going to go ahead and simplify that, get x squared minus 2x minus 3. And then just multiply this to that. That'd be x cubed minus 2x squared minus 3x, and then multiply the -2 through everything. That's a -2x squared, positive 4x, and a positive 6. X cubed minus 4x squared plus x plus 6. That's called standard form. You multiply it out to normal polynomial looking stuff. Not rocket science. Just one step at a time. Plenty of places to make mistakes, but it's not that, don't overthink it. No, there's 4. One's not a regular number. 1 is the loneliest number. You might catch that. It was a song. Popular song for whatever reason. All right, so let's try another one. I can't remember. It was before my time, but I remember it then. All right, so what are my factors that go with these zeros? 3, -3, and 4. All right. Is there 2 of them that it would be better to multiply them together first? Which ones? Why is that better to multiply them together first? Well, they're easy. They're the factors of a difference of squares, right? So that creates what is the answer when you multiply these two together? It's x squared minus 9, right? We know the middle pieces cancel out. And then you're just multiplying these two together, which is much easier than multiplying out the trinomial. So that's x cubed minus 4x squared minus 9x plus 36. So there's our standard form. Standard form is what we're going for most of the time. A lot of times on a quiz, though, I'll say, give me the factored form for half credit, standard form for full credit. That way you can, if you know how to set it up, you're good. And if you just make one small mistake on your multiplication, it could cost you the whole problem. So I try to do the factored form for half credit and then the standard form for full credit so that you're not just ruined by that. Let's look at this one. Zeros. 0, -2, 7. Let's see. What's the factored form? What's the factor that goes with x is 0? Just plain old x. And then x plus 2 for the -2 and x minus 7 for that. So then I'd multiply these two here together first and then distribute an x at the end. So that'd be x squared minus 5x minus 14. X to the third minus 5x squared minus 14x. So once you get this built here, it's algebra 1 work after you build the factors of the polynomial. Let's make it a little bit more difficult because it's too easy. Right? No, the reason we need to make it more difficult is because we got polynomials that have weird answers. So we got to know how to deal with them, okay? All right. Here's where it gets a little more algebra 2 involved. They tell us that the square root of 2 is an answer, is a solution to this, or a 0 to this polynomial. They tell us that 5 is. What they don't tell us is that if I got the square root of 2 as an answer, that came from probably either solving by square roots or by quadratic formula. What's always in the problem when you solve with quadratic formula or square roots? Plus or minus. So they told us 2, square root of 2, but they didn't tell us the negative square root of 2. So we have to be smart and know that that's there. They didn't tell us about that. What that's called is the complex / conjugate theorem. That's the name of the theorem that tells us this. If a radical or complex number is a 0, so is its conjugate. Conjugate just means change the sign in the middle. So this is a positive square root of 2. The conjugate of a positive square root of 2 is a negative square root of 2. Those are conjugates of one another. We'll do another one where it's like 3 plus square root of 4 or something, or square root of 5, something like that. And the conjugate's the minus in the middle. What that does is it creates this polynomial in factored form. I'm just going to put the x minus 5 first, the one that's not not a radical, and then I'm going to put the others. X minus the square root of 2. That's for this first one. What's the factor for x and the negative square root of 2? Be a plus, right? That's the factored form when you're dealing with that. Now, which two do you think you should multiply together first? The two that look alike, right? What's going to happen when you multiply these two together? X times x is x squared plus x radical 2 minus x radical 2 minus the square root of what? What happens when you multiply radical 2 times radical 2? I get radical 4, right? I still got the x minus 5 waiting to do his thing. What happens in here? They cancel out. The middle pieces cancel out. If you've got a square root still in your problem after you multiply them together, you didn't do it right. Okay? What's the square root of 4? It's 2. So that's x squared minus 2. And then x minus 5. So we've simplified this down to that. And then we can multiply by x minus 5. X cubed minus 5x squared minus 2x plus 10. So there's standard form for that one. All right, let's get a little tougher one. Here are our zeros. 4, 1 minus radical 5. And I didn't mean to write that comma. What else is a 0? Right. Know this, that's there. They don't tell you about it. It's there. Know it. Okay, that's the thing that's the algebra 2 part. You got to know that. So our factored form will be what? Let's get the easy one out of the way first. So if you answer first, you get to do the easy one. Thank you. Now, the others aren't that hard. X minus 1 minus radical 5. X minus 1 plus radical 5. Not any harder. Now, the multiplying may be a little bit more difficult, but writing the factors is not. One's it's always a minus right there, unless this number in front is negative, then it changes, double negative makes it a plus, is what happens. We'll see that in the next example. I'm going to multiply these two together first, because they should match up, right? Okay, so the x minus 4 is just going to be waiting in the wings. We're going to get these two together. Don't overcomplicate it. Just do distributive property 3 times. X times all 3 of those. That's x squared minus x plus x radical 5. Then negative 1 times all 3 of those. Minus x plus 1 minus radical 5. And then negative radical 5 times all 3 of those. Minus x radical 5 plus radical 5 minus radical 25. Again, x minus 4 is just waiting for the show to be over with. Now, everywhere you see a radical, it should go away. Okay, if you did it correctly, it should go away. So here I have a positive square root or x radical 5. Right here I have a negative x radical 5. They cancel each other out. Right here, I have a positive radical, or a negative radical 5. Here, I have a positive radical 5. They cancel each other out. What's the square root of 25? 5. So that radical is going to go away too. All right, so we have x squared minus x, and minus x would be negative 2x. All right? That turns into a minus 5, so we have positive 1 and a minus 5. Be a negative 4. Now all we got to do is multiply by x minus 4. That's not too bad. X to the third, 2x squared, minus 4x, minus 4x squared, plus 8x, plus 16. Simplify. Okay. Now, what letter are we on here? F. Let's do this one. Let's say we had 4, 3, and 3 minus I. What did they not tell us about? 3 plus I. Okay. So that's our bonus one that they don't tell us about. What are our factors? So for the 4, it would be x minus 4. For the positive 3 there, it'd be x minus 3. You guys got that. That's nothing to that. Let's get the imaginary stuff, complex. X minus 3 minus I, x minus 3 plus I. Which one's the hard part? Stuff with the i's in it, no doubt. It's longer. There's 3 pieces in there. But it's no different than the stuff with the radicals. We just got to remember some things about i's and I squareds and I to the thirds, what they turn into. So we got to remember that stuff. So we'll burn that bridge when we get there. So let's multiply first. We'll do these two. X times x is x squared. Oh, it's not. It's an easy one. It's popsicle stick bridge. It's that easy. And then plus ix. And then here we have negative 3x again. And then positive 9 and negative 3i. And then I'm distributing the negative I. So that's negative ix, positive 3i, and negative I times negative I, or positive I, would be negative I squared. Okay. I'm not doing anything with these others yet. We'll get there. Now, everything that's got an I should go away. Okay? I have a positive ix. Do I have a negative ix? Yeah. So they're going to cancel each other out. I have a negative 3i. Do I have a positive 3i? Yeah. They cancel each other out. Yeah. It is. It is. And it should happen that way. What does I squared turn into? Negative 1. Good job. So negative 1 becomes plus 1. So now I have x minus 4 times x minus 3 times x squared minus 6x plus 10. Because I have a positive 9 and now a plus 1. That negative I squared turned into a plus positive 1. So that's where the 10 comes from. Now, here's where your options come in. If you want to just multiply by x minus 3 to that, get that answer, and then multiply by x minus 4, that's fine. I'm going to take the root of multiplying these two guys together first, and then multiplying by a trinomial. Because it doesn't matter what order you do that in. This would be x squared minus 7x plus 12. And that's just FOIL method or distributed property, whichever way you want to talk about it. Negative 4x and negative 3x is where the negative 7x comes from. And then negative 4 times negative 3 is positive 12. That's where that's coming from. And then we're just doing distributed property after that, which is the fun part. X to the fourth, 6x cubed, 10x squared. And then the next line is negative 7x cubed plus 42x squared minus 70x. And then the 12 going through there be 12x squared minus 72x plus 120. Simplify, x to the fourth minus 13x cubed plus 5264x squared minus 142x plus 120. How can I check to make sure that's right? What did we do to check for zeros in the first section we talked about today? We graphed it, right? And then see where it crosses. It is highly unlikely that you multiply this out correctly and it still crosses at the right spots. Very, very unlikely that if you multiplied it out incorrectly and it crosses at the same spots. If you multiply it out correctly, this polynomial should cross at 4 and 3, and then it's not going to cross at those other two. Yes, ma'am.
Caroline bakes the chicken.
All right, good timing. We're finishing up. Okay. All right, so I'm taking some practice with this stuff. Excuse me. Tomorrow's practice day, so page 374. Let's do 11 through 18, and then 24 through 35. And then page 384, 10 through 31. And we'll just do odds on that page. And we'll just leave the other page on. So we'll do all of that. Because these get into the multiplying out the really long ones on 384. So work day tomorrow. Quiz Wednesday. If you missed the quiz on Friday, it's tomorrow. Since we're doing homeroom during skinny this week, you don't need to come out of there. I know juniors, you guys are going to get called individually to meet with Miss Bowen and stuff, so I don't want to mess that up because you don't know what order she's going to go in. So tomorrow during class time, if you missed the quiz Friday, let's make that up tomorrow, okay? And we'll go from there. It sure is.